Oh man, it's been a while. Let's just wait for this to get going and we'll jump into today's stream. Yep, that's all working. It's been a while, a bit rusty. There we go, that is all appeared to be working fine. Just drop my guy a message. What's going on, guys? Good evening. Welcome to a little Monday evening catch-up stream. It's been a little while. Hi. That is a big boy. What's up, Damien? How's it going, my friend? Got some amps on the way from you, I believe. It has been a while. Just a little chilled Monday evening stream. Nothing too crazy this evening, guys. I don't have a huge amount planned. Just wanted to kind of catch up with you guys, touch base, and just some company while I take all of the output MOSFETs out of this great big Ground Zero HC 10K high current edition. What's up, Donnell? Good to see you here, bro. It's a shame that we can't do the same thing how we do on TikTok, where we do a collaboration, a live stream on YouTube. Maybe you can do that now. I don't know. That's a little mids and highs amp you have there. Yeah, exactly. Just about to run my headphones off this, you know what I'm saying? But right, yeah, any news? Give me some life updates, guys. What have you been up to? What are you doing electronics wise? What are you doing sound system wise? Any other hobbies you got going on at the minute? Anything, projects that you're excited that you're working on at the moment? Hit me up, let me know what you've got going on. I would love to have a little chat about what you're doing. Ground Zero, I repair one at the moment, a 32K. Damn, yep. So those big 30, generally like the 20K, 20 to 30K boards, the single PCBs, I'm not seeing great reliability from those. So trying to achieve that much power density from a single board requires quite a decent amount of engineering and R&D and experience and knowledge that really I don't believe that any of the current car audio brands have the engineers with enough skills to actually produce something as big as that is stable and reliable. It can be made, of course. So I made this comment, what was it? Was it in a video, or was it, I think it was in a video, or maybe it might have been on a live stream. So where we are in the world right now with EVs gaining popularity, if you look at the motor for some of these higher power EVs, like the Tesla Model S, for example, the motors can demand in excess of 100,000 watts. Okay, so if the motors are that powerful, then there's going to be a motor controller driving them. Now, the way that these motors are run is not really that dissimilar to how Class D amplification works. You're essentially, the motors, from what I understand, require an AC waveform. I believe it changes in frequency. So you've got an AC waveform with variable frequency, and the way that waveform, the way that sine wave or modified sine wave is generated is with pulses, and IGBTs usually are pulsing to form a sine wave at the motor. And that is very, very similar to how Class D amplifiers work. So if you think about how powerful the motors are, there are motor controllers that exist that can deliver that amount of power and create a pulsed waveform to the motors with that much power reliably enough to last the car years and years and years, even doing, you know, big power pulls and stuff like that. So if you took that technology, if you took that engineering, if you took some of those engineers that designed those circuits and said, oh hey, so basically we want the same thing, except we want it a single output instead of 3 outputs, so if it's a 3-phase motor, and we want it to play audio, can you do that for us? And I guarantee they would be able to come up with a Class D amplifier in excess of 100,000 watts that is extremely reliable. It can be done, but yeah, none of the engineers working at these car audio brands, in my opinion, have either the time, the budget. I mean, maybe some of them have the skills, but the amount of budget that they'll get to design and produce a sort of 30, 40, 50k amplifier is very limited compared to the amount of budget that, for example, the engineers at Tesla would have to create a 100,000 watt motor controller. I repair my Audi too at the moment. Good fun. Best of luck with that. Still trying to avoid getting fines while testing bass. That sucks, man. In the UK, I guess you can technically get a fine, but you're never really gonna get a fine for like testing your bass out. Like if you cause enough of a nuisance that the police are called, they're just gonna come and they're just gonna say, you know, they're gonna say, well, what are you doing? Like you're making a whole bunch of noise. And you're gonna explain. You're gonna say, oh hey, I'm really sorry. Like I compete in this audio stuff, and you know, I'm needing to test it. And I felt like I was out of the way, and I wasn't, you know, going to be disturbing anyone. But you know, I guess I have. So apologies for that. I won't be testing here any longer. And they'll just be like, all right, well, no worries. You know, yeah, just don't do that around here again. I think if you were repeatedly causing sound nuisance in the same place, and you had multiple complaints, and you were caught multiple times in that same place, then yeah, you probably get, I don't know what it would be, because I'm not a traffic cop, a section something. You might get a bit of a fine, small fine, but nothing more than that. And in the worst cases, you might have your equipment actually confiscated. So yeah, if you had enough complaints against you, you might have your equipment confiscated. But generally, if you're, you know, first time offence, you're not going to have any problems. Just seen Lenny's 4 bass 30Ks coming from Brazil. Oh no! Did he actually go for them? Did he actually go for the bass 30Ks? Oh, Lenny. I'm pretty sure I had warned him, advised him against that. The Taramps bass 30K V2 are absolutely plagued. They're going to be on my bench. I've already got Lenny's 4 bass face 15Ks. Now, sadly for him, the bass face 15Ks that I've got here in my workshop aren't as a result of the amplifier just randomly failing. Unfortunately, it was a user error. I think he slipped and I think he shorted a speaker wire to the RCA or something like that. But they all went up catastrophically. Huge meltdown of all 4 15K amplifiers. So as a result, I mean, they're getting repaired, but by the sounds of it, he's gone for a bunch of the Taramps 30Ks V2, and they have an issue with the power supply section. So it's a design flaw, not designed very well. So unfortunately, I'm probably going to be seeing those again, and there's going to be more repair bills coming his way in the future. I see. We'll see whether that's the case. I'll have to come back and I'll have to clip this live stream if I get them on the bench at some point in the future. I'll be making a video of them for sure, and I'll send a little clip of this live stream. Currently trying to put together a dirty boombox with an 8-inch sub. If you're putting together a boombox, might I recommend a passive radiator? I got really into passive radiators recently. I don't think that they're really utilised properly in car audio. I was having a think about this the other day. So in the UK, something pretty crazy happened in the audio competition scene. So over here we have a competition series called Proper Droppers. You've probably heard of it by now. In my opinion, it's the best one of the lot. It gears you to produce and to build audio systems that can actually play music or across a range of frequencies. You test between 20 Hertz and 40 Hertz. And in one of the most extreme, one of the biggest categories that there is, the records were shattered recently. Now, if you'd asked me a while ago and you'd said, oh hey, what would be the best kind of enclosure design, or what kind of build would you do to kind of break these records to get as loud as you possibly can between 20 and 40, and typically all of the builds that have beat the records and that have been on top so far have been either just straight like ported walls, just like a basic big wall with a port in the middle, for example. You also have some sixth order walls as well, where you've got like a loading wall and then the subs are facing upwards and it's like a sixth order with a port at the back, and then you've got the loading wall with a bit of a port around it. They've been very loud as well. But recently the guy that shattered the record was running a fourth order wall. So similar to how I just mentioned there, where you got the wall with like the kind of high frequency port there, loading wall, and then you've got the subs on like a bed firing upwards, and you've got the ports at the back. He did that, but with a sealed chamber behind them. Now, in my mind, a sealed chamber, a sealed box compared to a ported box at a given range of frequencies that you're going to be looking at for this testing is going to be quite a lot quieter than a ported enclosure for that same amount of subs or whatever it is. So I've never really been a fan of fourth orders, because in my mind, you're just kind of limiting the output from that system to the displacement of the cones. The ported enclosure, or the ported side of that, having a port takes away the mechanical limitation of the driver at a small range of frequencies, and you're able to displace like considerably, like mountains more air, by loading the port and using that to displace the air rather than using the driver's cone. So yeah, ported and sixth orders has always been like, yeah, why would you not go for that? But what I hadn't considered is that given a fixed cabin volume, right, so whatever car it's in, you have however much space you have. Okay, now in order for a ported or a sixth order, a port loaded enclosure to work in a given space, there's only so many subs that you can load into the load chamber, for example, before really it's not big enough, and you're going to need more box volume, or you don't have enough space for the ports, for example. However, with sealed, you require a lot less enclosure volume for the amount of drivers. So if you take the same cabin volume, or the same amount of cubic foot that you've got available for an enclosure, and you can do a wall, and you can do like a sixth order wall, well, instead if you do a fourth order wall, you can put a lot more drivers in there, provided you have the space to fit, the actual physical mounting space to fit them, and provided it's not too small, whereby it's going to limit and really restrict the cones at lower frequencies. If you've got enough power behind you, and the drivers are strong enough and they have a low enough FS, then you're going to get more displacement from the driver's cones, because you've got a lot more drivers that you fitted in there than you were able to get from the drivers and whatever ports you could fit in the same volume. Now, this is very subjective depending on what build it is, but it seems like he may have actually come into something here, because the scores that he achieved, even at lower frequencies, I think were on par with or considerably higher than what came before with all the ported enclosures, and has the benefit of, obviously with it being a fourth order, the front chamber, which is the chamber in front of the subs where the wall is loaded, that's still ported, maybe like sort of 40 Hertz on the higher end. So that absolutely hums and is loud as heck, because at the higher frequency the drivers aren't really being restricted by the sealed enclosure as much, and the air spring in the sealed enclosure. So that's just basically like a massive 40 hertz ported box with like a lot of drivers in it. Okay, so that is very, very loud. And then on the lower frequencies, you have the safety of a physical mechanical subsonic filter. Essentially, that's like a sealed box will always mechanically protect against subsonics, provided it's not absolutely massive, so they have that benefit. You're not going to unload, and yeah, you've got a lot of control there, and it sounds great. You've not got a load of port noise. So yeah, I was like, wow, okay, where was I even going with this? We talked about boomboxes, but anyway, yes, fourth orders have my attention now. I was always a massive hater of fourth orders, but they got my attention now. Given us, if you have a limited amount of space, if you have the money and the power to just throw more drivers at it and throw more power at it, then that might be a solution to getting louder and also sounding really clean and being protected against unloading and a bunch of other stuff. Obviously, it's driver dependent. Not all drivers are working in fourth order, but that is definitely a consideration. But anyway, going back to the boombox thing. Yes, passive radiator is freaking awesome. I just picked up myself this old thing. I think these are kind of old now. This is an Earthquake Slaps 15 passive rad. How cool is that? It's brand new in box. This is the V1. This is not the V2. Apparently, the V1, which I've got in my hand here, the tuning is adjustable. But for the life of me, I can't see how. I can't find any manuals online or anything for these. I can't see any videos that demonstrates how the tuning is adjustable. So the way you adjust the tuning on a passive radiator is you add more weight, or you change the compliance of the suspension parts and stuff, I believe. But yeah, here doesn't seem to be any way to either add more mass or to adjust any of the compliances. But that's pretty awesome. 15-inch passive radiator. Now, typically, if you look online, if you read about passive radiators online, you will generally find advice given that says you should pair a passive radiator with the next driver size down. Is like what people have tended to kind of advise for a long time now. You'll find that everywhere online. Oh, you know, I've got this passive radiator. What size driver should I use? Oh, for a 15-inch passive radiator, good advice is to use a 12-inch active driver. You never want the passive radiator the same size as the active driver, because passive radiator is a port, but it's mechanically limited. So you want there to be a nice balance between being able to displace a lot more air from the passive radiator than the driver can, because that's the whole point of having that kind of reflex thing going on. But you don't want it so big that the active driver is just absolutely yamming around like fucking crazy and the passive radiator is not really doing much. So the advice has always been size down on the active driver. However, as active drivers, as subwoofers have progressed with their excursion capabilities, I actually see now a lot of the time, if you size down by 1, then you actually max out the passive radiator before the drivers really started working properly. So my advice going forward with modern subs is size down twice. So for a 15-inch passive radiator, typically, this is just very overgeneralization, but I would look more towards a 10-inch sub. Maybe even an 8 if the 8 is very long throw. So I have in the workshop, the subwoofer that I use in the workshop in here for just music while I'm working and stuff, it's a 12-inch passive radiator that I built using a blown edge subwoofer, and it's being driven by a 6.5-inch Digital Designs. It's a DD1506, monstrous little thing, probably one of the biggest, baddest 6.5s ever to grace the market. Now in that setup, that is 12, 10, 8, that's 3 driver sizes down. And yes, it is not completely, you know, the active driver is a bit too small. I run out of active driver, mechanical excursion, before the passive radiator really sort of, you know, is getting anywhere near its limits. So the best match for that would actually be an 8-inch. But if you're not trying to get the, you know, if you're not trying to absolutely crank it, if you're just listening to like normal music at a reasonable level, it is more than loud enough with the driver within its limits as it is. And having that much of a difference between the passive radiator and the actual driver size, I haven't personally noticed any downsides. It's not like it sounds uncontrolled or like delayed or laggy. It's very musical. It sounds great. Anyway, let's catch up with some chat. So yeah, for your boombox you want to be portable, and you want to tune as low as possible while being as small as possible. Passive radiator is the way forward for you in that scenario. Yeah, the Taramps HV160K, but they don't last either. You see so many of them just blowing up randomly. They're like a burp amplifier. They're not really designed to be reliable. They're designed to make a bunch of power for a tiny amount of time to put up a score. They're not designed for longevity. The thing is, Singron is when these amplifiers are like in the case and they're in a build and they're screwed to a sub box in the back and you're in the front, even though the output MOSFET's exploding is horrifically loud, it is genuinely like a gunshot. When it's like in the case and everything, when it's so far away, it's actually quite muted. I've been in a car when a big Korean, I think it was a 5K, went bang, and the MOSFETs were completely obliterated. It looked horrendous, but I didn't even hear a bang sound. It just kind of like sounded like the subs made a small pop sound, and that was it. So yeah, I think it's not too scary when it's actually situated in the build, but when it's on the bench in front of you, completely open, yeah, it's terrifying. It's fucking absolutely loud as heck. Makes your ears ring. You got the dee sound in your ears afterwards. Horrible. Thoughts on the Sundown Salt 4K. So not many people in the UK are buying Korean amplifiers anymore. So it's actually been quite a while since I did any big Korean repairs. Everyone in the UK is buying Taramps or Powerus or the Chinese Sound Digital clones, the really cheap crap. That's what everyone's buying. People aren't buying new Koreans. They're so expensive over here. And I generally advise people not to bother buying them because they are wildly expensive for the power that they make. They're old, outdated circuits, and they cost an absolute bomb to repair. So not many people over here are really buying them. So as far as I'm aware, there's not really many Salt amplifiers in the UK. I do have a Salt 12 here in the workshop for repair. That's going to be a big bill. But that's the only one that I've ever seen. I haven't seen any Salt 4s, Salt 8s, or anything else, just the 12 here that I've seen. So I can't really comment, but what I do know, I think it's the same circuit as the Digital Designs. What's it? The new M4000. I actually did a video. I've got a video of the Digital Designs M series. I think it is the 4000, a new one. I say new, it's like a few years old now. But I think it's the same board design as the Salt 4. So go check out that video that I put up of the M4000, I think it is, and that will give you an idea as to what I think about the Salt 4, because it's the same basic circuit layout. How much did it cost for Big D to send you an amplifier? I don't know, but I know that the shipping for an amplifier sized box from the States to the UK is somewhere around 120 to 150 bucks, I believe. And that's just the shipping. That doesn't include the import tax and duty and everything else. So it's wildly expensive to ship stuff from the States to the UK. You know, if it's like something of a decent size like that. I have a 20k for myself. A Sound Digital 20k power. Like out of all of them, Sound Digital are probably the ones to design a decent 20k. 20k is kind of on the limit for me as well. I think that you could, yeah, 20k. I would not hesitate to recommend, provided it was proven to do well and to last alright. But anything more than that, like 30k in a single board, nah, not yet. No one's really designed anything good enough yet for that. How do I get in contact with you for an amp repair? Well, you need to live in the UK first of all, because I don't take work from overseas, but you can just contact me via my BearVids Facebook page first and foremost, and we'll go from there. I saw his failure looked like rectifiers. No, his amps all below output MOSFETs and power supply MOSFETs. The rectifiers, I believe, were fine. Hopefully Tamp's fixed that. Nope, they haven't fixed it. Like, to fix that, it's a board redesign. They're not going to do that all like for this current line. They might make a V3 in which time they'll fix it, but all the V2s are going to be the same and they're all going to explode. Do you use moving microphone and DSP to tune environments? Depends what I'm doing. Typically no. Like for my own stuff, not really. I use RTA in my own builds, in my own cars, but I generally always tweak the, like I'll sort of get it perfect on the RTA based on how the graphs should look and on paper how it should look. But then I always tweak it just based on my own personal preference. I think that music has to be fun to listen to, okay? And fun to listen to doesn't always necessarily mean clinically perfect and accurate in terms of frequency response and stuff like that on paper. I think that most of us can agree, I think most of us here will agree that the most fun that you ever had with audio was when you knew a lot less. When you were putting systems together and you kind of, you bought a bunch of stuff, wired a bunch of stuff up, you didn't really have a great deal about what you're doing, but you knew enough to be able to do it. And you were maybe getting cheap stuff off Marketplace, off eBay secondhand, putting together what you had, and then listening to it, and you were like, oh damn, this sounds really fucking great. This sounds really fun. It's punchy, it's bassy, whatever. That's where the fun is, I think, in audio. I think once you get to the point where you know so much that you start doing crazy tweaks and stuff, it starts becoming a little bit less enjoyable. I think it's adjustable with the center mass or of deep it sits in the box like a spacer rings. Okay, I don't have any of that, and I haven't seen any of that online in any pictures or videos of these. So yeah, I'm not sure. I think I might just be stuck with whatever it's currently tuned to. I have a Salt 1 in Germany. What's a Salt 1? Is that like a 1K? 1K amplifier? Don't think I've ever seen that. The smallest one that I've ever heard of is the Salt 4. Like I say, we don't really get them over here in the UK. Audio was definitely cheaper when I knew less. Yes, that is a thing. Yeah, I think the most fun I had was definitely just like earlier on days in the Proton, buying like Pioneer subs off Marketplace and keeping things relatively simple. I have a B2 Rampage 8 and Sundown Salt 1 in my Mercedes in Germany. My brother paid $470 in the USA for it and sent it to me in Germany. The amp here sells for $899. Yeah, that's crazy. I think that's the same thing as over here in the UK. The prices are just kind of wild because of you know, the costs involved in getting them here. So it doesn't make any sense when you've got the ability to purchase like a 5k amplifier here for £250, brand new with warranty. It doesn't make any sense. Power versus cost. Yeah, glue some weights to the back. Yes, I can use some tyre balancing weights is a good one you can use. What did I do with my bag of FETs? Ah, yes. Is Big D's amp still with you? Yeah, I've still got the audio pipe here. It's actually completed. I just need to put it into the heatsink, and to do that is complicated a little bit because I've fitted a lot bigger MOSFETs in there, so I need to kind of rework the heatsink so they'll fit. So that's just what the hold up is on that at the moment. That is 32 brand new output FETs. So this one, I believe, has drive circuit weirdness going on. It's a big one. So I'm just going to have a little peek over here at the drive circuit and see what we got, see what I can find. So we should have some continuity here to the drive circuit through the gate. $59 ohms. And over here to the driver. Yep, there we go. And we have feedback there. So I'm going to solder these feedback resistors back down. I'm not sure why I removed those. Yeah, the board is very flexible on this one. It's crazy. So this is a ground zero GZPA 10K HC. This is the high current version. They made a few different versions of the 10K. This one is high current. It has 32 output MOSFETs, which is a lot of output MOSFETs for a 10K. The power supply is absolutely huge as well. Tons and tons of, I think they're 1405s, IRFP 1405. Absolutely crazy. So this thing should be a 0.5 ohm monster. But right now it's a 0.5 ohm sleeping thing. Yeah, so I had a look at the cost of the output FETs earlier. Fortunately for me, at the moment, FDA 24N40s, which are the output MOSFETs that this amp uses, are not too expensive right now. I can get 32 of them for about like 70, yeah, about £70 in the UK. So that's maybe like around $100, which is, yeah, expensive, but it could definitely be worse. I've seen them be a lot more expensive than that. I'm using a home subwoofer amplifier plugged into a power inverter on 75 watts. Oh no, don't do that, Dean. That's a really terrible solution. Yeah, you need to get a car amplifier for your car system. Most of the time these days with modern, even if your car's not that modern, but with a standard vehicle electrical system running efficient Class D, modern Class D amplifiers, you can easily run 1000 watts or 1500 watts RMS without even having to think about the vehicle's electrical system. So just stock electrical system, you can most of the time happily run 1000 watts RMS, 1500 watts RMS, and not have to worry about adding extra batteries, upgrading the alternator, yada yada yada. I mean, if it's the tiniest car in the world with like the tiniest alternator, like a 40 amp alternator or 60 amp alternator, then yeah, maybe not, but I'll show you what else I've got kicking around. I have a Sundown NS2 here in for repair. Should we have a little peek at this? Am I going to be able to lift this up from the chair here? Woo! Sundown NS2, which is basically a Digital Designs Z2C, I think, very similar circuit design. Why do full bridge amps and half bridge amps sound so different? They don't. I made a video showing that they don't. I literally made a video showing that they sound exactly the same. So you can go and watch that if you want the answer to that. Thanks for the knowledge, Sam. Don't know how I would design it. Maybe copy JBL and rock 2 radiators. Yeah, you can do. You can rock 2 radiators of the same size as the active driver. Just make sure you get the balance right. Don't know about ventilation for the amps. I relied on the port for that. Oh yeah. Well, the ideal thing for that is to just thermally couple the amps heat sinks inside to a bit of metal that can vent to the outside. That's how they usually do it. You know, like a plate amplifier. Got an active subwoofer with a plate amplifier on it that has a heatsink on it. Yeah, you can do it that way. You should explain optimization comparison on why some amplifiers like the base phase 15K has whatever amount of output components compared to the times 15K. Yeah, I could do a video on that. You don't need a lot of money to get a basic car audio setup now. Like amplifiers that make 1000 watts RMS, you can pick up for absolutely dirt cheap, like barely any money at all. 20 bucks, 25 bucks. It's very, very easy to get into car audio now. Checking over here, the FETs come out to €80 for 32 FETs. Yeah, it's not too bad. The FDA 24N40F are not too expensive right now, to be honest, on the market. They're actually alright. This board is so big that I can't ever really like keep the camera pointed at the bit that I'm looking at. So currently I'm way off to the left here, just soldering these feedback resistors back in. I would love a video repairing that NS2. I might consider it. Oh, done something to my camera here. That's not working. What's wrong with the camera? I am frozen. There we go, we're back, I think. No, we're not. Frozen again. The Canon camera is not happy today, is it? I wish 1K amps were that cheap here. For €35 you can get a Class AB 4 channel with half the screws missing. I mean, here as well, you have to look around a bit, and you have to be lucky, but they do exist. I think probably here, yeah, £35, £40, you'll be able to pick up like some old Kicker KX1200 or something that looks like ass, but actually is really good inside. Baseface DB 1.3 you can pick up for really, really cheap. Video repairing the NS2, yeah, maybe. The NS2 has a completely cooked output section. I'm not sure if I've done any videos on that circuit before. I'm not as experienced in that circuit that the NS2 uses compared to Brazilian stuff like clone stuff and JL audio stuff and Rockford stuff, for example, because I don't work on as many Koreans as like some of the American techs do. Like, I definitely know my way around it, I definitely repair it really easily, but yeah, in terms of like deep experience and knowledge with those circuits, like I haven't repaired hundreds of them, but I know a lot of the techs in the States have, so they might have more information about like common things to check, things that maybe fail sometimes or get weakened by the failure, etc. So I might have a word with them just to kind of grab any additional info, and then I can do a video on it perhaps. I just found two 300/4 for $50 a piece. That's awesome. Yeah, the JL amplifiers all suffer from the dirty switches and potentiometers, and people get rid of them because of that, even though they're actually fine. Even though they're actually fine inside. Alright, I'm just going to power this this big Ground Zero 10K up, because I want to check to see what the drive circuit's looking like. So like I say at the start of the stream, I've had this one on the bench here. Well, no, I've had this one in the workshop on the top shelf for about 4 years now. Now I will tell you a little story about Koreans and mistakes that I made a long time ago, probably like 6 or 7 years ago, when I was repairing Koreans a lot. So when I first started out doing repairs, and I got these big Koreans in. The big Koreans were some of the first amps that I learned to repair on it, along with the Banda Viking series amps. And when I first started out, I would see blown components and I would replace them like for like. So if an amp had blown 24N40F output MOSFETs, then I would order 24N40F output MOSFETs. I would order like for like parts. Even amplifiers that had random ass power supply FETs like IRF 1010E or like IRF 44Z or like the 50NF06 or just random stuff that 3205s would be fine for, I would be searching for and buying the original MOSFET model, because I didn't know enough about amplifier repair to know that, oh man, the power supply doesn't fucking matter, just drop in some 3205s, drop in some whatever, it'll be fine. They're really not fussy, so I was buying the exact parts that were failed for every time because I didn't know any better. I was just replacing what I saw that was blown, and that worked great. That was great. Amps were getting repaired, stuff wasn't really dying on the bench, and it was all good. And then as I got more experienced with amplifier repairs, and I started noticing the data sheets for the components and their limitations, and how close some of these amps are running their MOSFETs to the MOSFET breakdown limits, I started to get a bit uncomfortable with some of these big Koreans. Okay, they're running 24N40Fs, which are 400 volt MOSFETs in the output section. The rail capacitors are 200 volts, obviously that's per rail, so that's 400 volts. So the capacitor limit and the MOSFET limit, 400 volts. Now this thing on the bench right here, when this is running up at like high 14s, like into the 15 volts, I think this is 16 volt stable perhaps, but yeah, when it's running like, you know, definitely up to 16 volts, I'm pretty sure the rail creeps above 400 volts at some points. So, and even when it's running at like 14.8 volts, the rails are like high 300s, and I just didn't sit well with me to be running the MOSFETs that close to their breakdown limits. So in my infinite wisdom, however many years ago, I was like, I'd rather use some 500 volt MOSFETs, because I'd seen some bigger Korean amplifiers use the 500 volt MOSFETs, 20N50 for example. So I was like, well, I surely it would be better and potentially be more reliable to run the MOSFETs not quite as close to their breakdown limits, like you see in reputable brands of amplifiers like Alpine, for example, are using, and Pioneer, they are reputable amplifier manufacturers. They don't make big amps, but the really reputable, tried and tested GM D9701, 9601, they use 200 volt output FETs in an amplifier with rails barely at 100 volts. It's like half. So, and in a lot of reputable like brands that really know what they're doing, they will spec the MOSFET breakdown voltage limit way higher than the rails are, and those amps are typically very reliable. So in my infinite wisdom, I was like, right, well, I just want to use some 500 volt FETs just to get it a bit further away from its limit. And when I started doing that, I didn't really realize it at the time, but amps started dying during my endurance testing, or after a few weeks back with the customer. Output section, the FETs just started blowing up, and I wasn't really sure what was going on. I thought maybe we had bad batches of drivers, maybe I'd missed something, maybe just a whole bunch of stuff, and wasn't really. I sort of lost my confidence doing Koreans, the big ones especially, for a while. And then we had COVID. Like after that sort of loss of confidence and stuff, we had COVID and couldn't get output drivers, 21844S. So I was buying IX 21844 drivers, which are on paper identical to the IR part. And I also tried the FAN 7939, which is a compatible replacement chip for these. And yeah, they weren't. These chips weren't doing a good job. They were failing. They were causing the amp to fail. So I just had a sort of string of like big Koreans just not really having a great time repairing them. But then over the last couple of years, I sort of thought back to my experiences with Koreans, and I remember specifically a couple of times I always used to fit one MOSFET per bank in the output section after the drive circuit repair, just to check that everything was all right. I would just fit, say for example, I've got 16 MOSFETs on this side. I would fit, what was it on this side? I've got 4, so I'd fit 1, 2, 3, 4, 5, 6, 7, 8. I'd fit like 8 MOSFETs, maybe even 4. Hang on, low, high. Yeah, I would fit 1, 2, 3, 4, 5, 6, 7. I'd fit 8 MOSFETs, 1 per bank on this amplifier, instead of the 16. So half the number of MOSFETs. And in some cases, with amps that only have 2 output inductors, I'd fit, even less. It might be like 4 MOSFETs per side, just to check that everything was all right. So that if anything did go wrong and I'd missed something and the MOSFETs died, I only lost a couple of FETs rather than losing like 28 of them or something. And what I noticed is that while the voltage was kept at 9 volts, 10 volts on the power supply, the amp would work fine with these limited number of output FETs in. But then when I increased the voltage beyond like 12 volts, 12, 13 volts, pretty much every time output MOSFETs would explode. And initially I was like, oh, I've done something wrong here. I missed something. But then I started to learn that by fitting all of the output MOSFETs and not really changing anything, they stopped blowing up. So I was like, right, okay, don't put one MOSFET per bank, it doesn't like it. So all these years later, I started to think back to why is that the case, and it's to do with how far the drivers are from a lot of the MOSFETs here, and also how many MOSFETs are run in parallel on a driver. The gate capacitance, the exact characteristics of how the gate drive is kind of calibrated between the driver and the MOSFET and the gate resistor in these amplifiers is very sensitive, it turns out. So the reason that the single FET in per bank were failing was because by running only a limited number of FETs, I was drastically reducing the overall gate capacitance for that driver on that bank, and that was not how that drive circuit was designed. So the difference in total gate capacitance as a result of the lack of FETs was causing me to have dead FETs and causing them to blow up. And then I thought, hang on a minute, I had these problems when I was swapping out the FETs from 24N40s, for example, to 500 volt parts, and it's very likely that I was having problems because the gate drive characteristics of those replacement FETs, the 500 volts that I was fitting, they were either more or less gate capacitance, or slightly higher or lower gate charge, or slightly different timings, and that was causing the whole thing to be unstable. So recently, when I've got big Koreans in for repair in more recent times, within the last few years, I've just been fitting original parts. Even if the rails are really close to 400 volts, just put the original parts in, get as original drivers as I can, the IR version rather than the IRS version, and haven't had any problems. So yeah, this amplifier right here, even though it's a monstrous 10K, the caps are 200 volts. The output MOSFETs in this would have been FDA 24N40F. So even though it's really close to those limits, that's what we're going to be fitting. This one has 39 ohm gate resistors, and most of the ones that use this output section design that run like 28 output FETs, they use 47 ohm gates. So it looks like the more gate capacitance you have, the lower value gate resistor you need per MOSFET. Thank you very much, Jukebox, for the £10. That's a very kind donation there, my friend. I really appreciate it. I cannot wait for the audio pipe vid. Hope this helps with the parts cost. Always, man. That's really kind of you. I just need a little gap in my repairs coming in to just spend some time to reassemble the audio pipe into its heatsink, like in a really good way, so that everything is cool with the FETs on the heatsink. And I also need to work on Boomer Bus Season 2 as well. That's another story. That's going to take ages. I ran into issues with the PT Cruiser with that. I remember back in the day, Perry yelling at me for trying to upgrade FETs in an amp I was having trouble with. Yep. So obviously, Perry, being the more experienced one, knows exactly what he's talking about. And so, if he starts yelling at you for doing something, listen. What's up? What's up, Jarrett? How's it going, my friend? Okay, let's put some power. Just before we put power, I'm just going to go over with the multimeter. We don't have any output MOSFETs in here, so there's no risk really to anything catastrophic happening. I just want to make sure there's no obvious low resistances on any of these drivers. Oh, sorry, yeah, on any drivers, yeah. That's looking good. Okay. If 400 volt MOSFETs are good enough for the factory, they're good enough for the repair tech. Yeah, there is that, but I also don't necessarily trust all of the factories all of the time to do the correct thing or to make the right choice. For example, in these exact same amplifiers that I'm talking about with 24N40Fs, there is a poor design choice, design flaw, if you like, with how the plus minus 15 volt auxiliary supply voltages are done, and it causes the output MOSFETs to explode. So yeah, you know, while the factories obviously do know a fair bit, they aren't immune to making mistakes, and they aren't immune to not necessarily making the best choices. The factory's incentive is to make money, and in a lot of cases the cheaper component will be chosen because it's cheaper, even when a better suited one will exist. As long as the amplifier makes it out of the warranty period, the factory doesn't care. So if the cheaper part allows the amplifier to last for long enough that it makes it out of the warranty period, then they're going to go for it. Doesn't necessarily mean it's the right one for the board. So I'm going to stick this right down at like 9 volts. I want as less amount of rail voltage as possible. We're going to turn the 9 volt protection off. There's a little dip switch on the driver card here for shutting the amplifier off when it dips below 9 volts. We're just going to disable that for a minute. Just want to keep the rails as low as possible while I test the drive circuit out here. Okay, there we go. Ooh, there's a lot of current in this. A lot of rail capacitance in this. Right, so we have a bit of negative rail there, we've got positive rail there, so that's our high side. Negative, 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 positive. Okay, so what we shouldn't have any DC on low side drain or high side gate or source, which we don't on either that side or this side, which is very good. Yep, okay, that looks safe to continue with the power up. Okay, there we go. Alright, 3.7 amps idle current draw with 9.1 volts. We have PWM there. Yep. So we have 1, 2, 3, 4 MOSFETs per bank. So that bank's okay. That bank's okay. Let's go over to the other side. That bank seems okay. And that bank seems okay. So the drive circuit is up and running. And the last time that I had this amp on the bench and had it sort of running, it was behaving really strangely. I was getting weird glitching in behavior, but I did have those G20N50 output MOSFETs fitted, so I think I just need to go ahead and order 32 24N40s for this, and it's probably going to be alright. I've got a different model of high side bootstrap diode fitted, but that should be okay. You replied in the comments in the video full bridge versus half bridge that both amps are full bridge, laughing at me. No, so the Crown A6000 GTI isn't really full bridge in the same sense as like the Brazilians. It's 2 channels that are separate. They're not on the same. They're not a mono full bridge amplifier in the same way. But either way, they do sound the same. Like I say in the video, I think I mentioned in the video, the differences that you experience between Korean-made amplifiers and Brazilian-made amplifiers is the way that the preamp circuit is designed is wildly different. The Korean amplifiers have a much steeper low-pass filter roll-off, and the low-pass filter goes much lower. Like some of the Koreans, the minimum position is like 30 Hertz. More typical is 40 Hertz, Whereas the Brazilian amplifiers, the minimum position will be 80 Hertz. So a huge difference in how the low pass filter is set up on these amplifiers, and that drastically changes how the amp sounds, because the more aggressive low pass filter you have, the amplifier is going to sound like it produces lows better, it's going to sound smoother and cleaner, whereas trying to play 80 to 120 Hertz from a car amplifier into a modern car subwoofer sounds horrible. It heats up the coils, it's going to start smelling, and it's going to sound like the amplifier is lacking on the low end because you're getting a lot of higher frequencies come through at high power. That's the main difference between the amplifiers. It's not the amplifier stage that is causing these differences in sound, it's because of the preamp side, and you can mitigate that by running an active low pass filter in line with the Brazilian amplifier, either on your head unit via a active crossover like a line driver, or via DSP if you want, but you don't need a DSP just to run your subs, that's a big waste of money. But the amplifier stages themselves on the subwoofer application, there's no perceivable difference really in how they sound. Can't wait for you to get the Tyrants 30K so you can explain what's up. Absolutely, I am excited and also not excited. I'm excited to get the Tyrants 30K because it'll make a great video and hopefully I'll be able to explain what they've done wrong in the design. But if I get a Tyrants 30K, that means that probably Lenny's Tyrants 30K has failed, which is sad, and I don't want it to fail because he's had enough bad luck with his 15Ks as it is, so I don't want to wish that upon him. But it would be good to have one in the workshop. I appreciate the help and contribution on the Facebook page Based UK Audio. No problem. Anytime. Is that just a sound digital Tyrants thing? My Paris was -3 at like 8 Hertz. The Paris are a lot better with the low pass filters for sure. But what right there, you're talking about the high pass filter, 13 BTRX. I'm talking about the low pass filter. Right there, you're talking about the low frequency roll off as the frequency starts decreasing. Earlier Brazilian amplifiers, like the early Tyrants, started rolling off. They had like a built-in high pass filter, built-in subsonic filter, start kicking in like around 25 Hertz or like 28 Hertz. Not the case now, but I'm talking about the low pass filter being too high on the Brazilian amps and people running them too high. I recently got a Smart 3 bass for free. It was sticking out of a trash can on the side of the road. Repaired it and replaced my old Rockford Fosgate 500A2, and it's light years better on two JL8W1s. Hell yes, exactly. Glad that you had that experience because there's no reason that it wouldn't be. It's wildly efficient, fantastic circuit design. It's a lot of power, which is what you want. Subwoofers sound best when you have excess dynamic headroom, which is why I recommend people just get the most power that they can afford for the build that they're running. Doesn't matter about the RMS matching the subs. Just get as much power, get as much rated power as you can for the application, and then calibrate the amplifier to the next limit down the chain, whether it's the subwoofer's limit or whether it's the vehicle electrical system limit, whatever the limit might be, but don't let the limit be the amplifier. So get as much power as you can. What are the most common reasons why my amp blows out fuses when I connect it to my sub and play for like 5 minutes? So if the amp is playing, albeit for 5 minutes, then the amp is likely fine, doesn't have a fault. So fuses will blow when excess current is poured through them. So it would help if you told me the make and model of your amplifier and what rating fuse you're fitted. What are you working on today? Ground Zero GZPA 10K-HC. That's what I'm working on today. But I need to buy some output MOSFETs for it. So looks like I can buy some output MOSFETs for this. Let's have a look. We go to uk.rs online. That is the website. RS Components UK. I guess I just haven't visited it on Firefox before. Click and hold to see a preview. That sucked. FDA 24N40F. Yes, please. So I need 32 of these. Now, the cool thing is that I recently purchased a lot of these FETs for a couple of Sundown NS1s and some other stuff. So I have a couple of 24N40Fs that will be the same batch as these ones that are going to arrive. So although I need 32, I actually only need to order another 30 because I will have a couple spare that will be the right batch for this. So that's pretty cool. I'm just going to quickly log in, see how much this is going to cost. Says currently unavailable now. Weird. No, I don't want 60. I just want 30, not 60. Hey. Currently unavailable. Are you sure about that? Ah, limited stock. 30 left, ready to ship. Alright, so I don't know why I added 60. I'll just add 30. There we go. Very good, very nice. There's only 30 left. Oh my gosh. I better order these then because they'll be the right batch. And if I don't order them and they go out of stock and I have to order them from somewhere else, there'll be a different batch and then I can't use the extra 2. Alright guys, let's get these ordered then. Yep. Check out securely. How much expensive equipment has ended up in the trash? Absolutely, yeah. It's like generally so much like working stuff or repairable stuff has been thrown away over the years. Quite sad. What do you think of the Dynabel BF7501? No idea. Never heard of that before in my life. Let's do a quick Google to see if I can see a board picture. Oh, looks like a generic kind of. Is that a Korean? Picture. Oh, that's so resolution. I can't make out what drive architecture that is. It looks like really old school half bridge vibes. Oh yeah, it's got the upright drive card. I think it's got a. Has it got a pair of output inductors, or has it got 4? A pair of them. Yeah, so it'll be just a dual 21844S. Yeah, worth repairing, man, for sure. Yeah, nah, man, repair it. It will do someone well. I ended up talking to the owner. He said it just stopped working one day. It needed new output FETs. Man, if all of the amps that got thrown away because they stopped working just magically appeared in my workshop, that I'd be so happy. I'd just fix them and sell them all day long. I need to repair my own Ground Zero 1K. Had stripped output screws, just need to drill and tab. Oh, I hate it when that happens. May I ask a question? So I replaced an A940 and 2SC2073 pre-drive transistor on my amplifier and a 100k ohm resistor of 5 watt because they were shorted. Resistor on fire. How the hell is a 100 kilo ohm resistor on fire? A 5 watt. Should we do some maths real quick here, guys? I'm not. That's the maths ain't mathsing. Hang on a minute. So, in order for that resistor to be on fire, okay. So so it's a 4 watt resistor. Okay, so in order for that to be on fire, let's say that there ended up being 4 watts continuous. Let's say that there was 16 watts going through it for it to be really on fire. Okay, well, I don't know, let's go 12, 3 times the rated power. Okay, and it is 100,000 ohms. How much voltage? 1,000 volts would be required across that resistor for it to be sinking 12 watts of power. So I think, my friend, something is wrong there with the information you have provided. I don't believe that you had a 100k ohm resistor in a car amp and the resistor was on fire. Oh no, sorry, it's a 5 watt resistor. Okay, that's even worse. Yeah, that'd be even more. For a 5 watt resistor to be on fire, it would need like 20, 30 watts through it. So it's going to be thousands of volts. Did you ever finish hot rodding the base face? The base face 5K, I made it into a 2 ohm version. I did. I made it into a 2 ohm version. Yeah. I did. I finished it and I sold it and it's working well. Yeah, working great in the guy's car. So yeah, it's all done. You took my FETs. Jarrett, where are you based? Because I only bought them from the UK supplier, not anywhere else. If you're in the States, then you're fine. You still got them. How's the Sundown mute circuit repair doing? Did I do that on live? Oh no, I did that on video. Yeah. I can show you a picture. No, I can't. How can I show you a picture? I'll try and show you a picture. How can I show you a picture? I know. Quickly logging into my Facebook. So I had a Sundown NS1 come in, and I was repairing it, and I got to the stage where it needed the drive circuit checking to make sure that it was fine before I fitted new FETs, and I wasn't getting any drive. From the drive circuit, but so basically the IRS 21844S were in shutdown, and I couldn't figure out why. The muting circuit, which is in front of the driver card in those amplifiers, was telling the drivers to mute, to shut down. And I couldn't figure out what was wrong with it. I couldn't find a single bad component anywhere on the muting circuit, on the driver card. I replaced a bunch of stuff, and yeah, it was... Oh, Firefox has crashed. Lovely. Guys, if you ever want an advert for Firefox, there's the advert for Firefox. Firefox crash report. Lovely. Try that again. So I couldn't find any components that were dead on this muting circuit or drive circuit anywhere. So let me show you a picture of what I ended up finding, which was the problem, which I'd never seen before. It's taking a while to load, just bear with me. Having to scroll up in the conversation to get to the photo. Here we go. Right. Make sure you can see that. Yeah. Okay, so this right here is the Sundown NS1, and I've removed all of the blue film capacitors, which are usually here in between the output inductors. And there are a couple of traces here that run from the power supply driver card area all the way up to the output driver card. Now right here, underneath the blue capacitor, which you can see there, some moisture had built up and it had corroded and eaten away these two traces. And one of these traces was the trace that was responsible for sending the mute signal from the power supply drive card, drive area. It sends a mute signal up the board to the output drive card so that when you remove the remote, the output drivers switch off before the auxiliary supply voltages disappear. And so basically, that's why this trace was broken, and it was locking the this was all messed up. It was locking the output drivers into shutdown. And it took me ages because I was looking for a bad component. Never in my life did I think that underneath the blue capacitor, where I couldn't see, would be a trace that was corroded with moisture, when there wasn't a single other bit of evidence on the board anywhere that there was any moisture, condensation, corrosion. Like, there was nothing anywhere else. It was literally just under that cap. There was nowhere else. So yeah, very difficult to find. Good evening, Nitro. I'm planning to run a Digital Designs Z2B in half ohm. Got plenty of power from a 16 volt lithium battery. It should work very well. What do you think? I'm not so sure. So there is a misconception, okay, among car audio enthusiasts that in order to run reliably and safe at 0.5, you need mega voltage. You need mega power supply. While yes, you do need a big supply, because running a, what is that? It's a 12k amp, okay? Running it at half ohm, you're turning the 12k amp into a 24k amp on paper, okay? You do the maths, you take however much voltage and current is required for 12k at 1 ohm, you then plug 0.5 into that equation, and the power then equals 24k. Now obviously it's never going to make 24k because you run into board limits, voltage sags and limitations across the board, but essentially you are asking the amplifier to do twice the amount of work that it wants to do at 1 ohm. Okay, so yes, you now have a much bigger amplifier, so yes, you need to supply it with more current. You need to supply it with more current. What you don't necessarily need to or even want to do is run it at 16 volts. Okay, so the Z2B amplifier, I can't remember off the top of my head, but let's just say for argument's sake in this example, it's a 12k amplifier and it produces 12k. The amplifier board is designed to safely produce 12k at 1 ohm pretty much all day long, on music, whatever, as you like. Now that amplifier will run at 16 volts. Now when you run it at 16 volts, instead of being a 12k amplifier, because the voltages are higher going in, it results in a higher rail voltage, so therefore the amplifier can now produce 15k at 1 ohm at 16 volts. Awesome, you've now got a slightly bigger amplifier because you've given it more voltage. So it's a bit more power. Perhaps the design accounted for that. Perhaps the designers, when they were designing the Z2B, accounted for, okay, if we're going to make this amplifier stable up to 16 volts, then we need to make sure that the board can safely provide the amount of power that this is going to make with the increased rail voltages that are generated at 16 volts. So 15k, all right, yeah, probably there's enough headroom in the board for it to be fine on that, and they tested it and it was. However, when you then combine 16 volts, which is already more power than perhaps the board was maybe optimized for, and then you 0.5 it until you double that, you've now got the amp turning into, on paper, a 30k amplifier. So if you're gonna wire at 0.5 and you're gonna run the absolute maximum voltage that you can into the amplifier, you are literally asking for every ounce of, like, you are stressing that amplifier to its absolute limits. I mean, you're already above the limit because you're at 0.5, but even with impedance rise, people don't realize that impedance rise only really exists after the first couple of cycles of the sine wave. So if your subwoofers are at rest, okay, if you're wired to 0.5 and you've calculated or you've measured that, you know, at 30 hertz you rise from 0.5 to 1.2 ohm. Okay, so you're like, oh, that's fine. I'm above 1 ohm. Yeah, it's fine. I'm rising above 1 ohm. That's only once the subwoofer has got going. During those initial few cycles, or definitely the first cycle is the most important one here, you're not rising to 1.2 ohm. The amplifier initially, when it first sends the first bit of the sine wave, initially it is seeing much closer to 0.5. It won't be exactly 0.5, it might be like 0.6, but it will be much closer to where you're wired to than what it rises to. And the reason for that is because obviously the back EMF, or the impedance rise, is not instantaneous. It takes time for that to happen. The same reason that you may have noticed, if you plug in your vacuum cleaner at home, okay, which has a high power motor inside, plug it, your old school vacuum cleaner, into the mains. When you turn on your vacuum cleaner and you look at your lights in your house, you look at your filament light bulb, it might not happen so much with LEDs, but definitely with filament bulbs back in the day. When you turned on the vacuum cleaner, there would be a spike of current as you turned it on, and the lights would sort of dim ever so slightly, just marginally, just a little bit of dimming from the lights as you hit the power button on the vacuum cleaner. But then once the motor got up to speed, it was fine. The lights didn't, you know, they weren't constantly dimmed. It was fine. You just notice a slight flicker when you turned it on, and that's because the motor was at rest. And it wasn't spinning, so therefore it wasn't generating that back EMF, and there wasn't any impedance rise. It's the same thing that happens with subwoofers and amplifiers that are running them. To get the thing moving, there is a spike of current where the supplying voltage, the supplying device, sees the resting nominal impedance of that wind, of that coil, whether it's in a motor, whether it's in a voice coil, etc. So if you're wired to 0.5 and you hit a sharp bass tone, well, the amp's going to see almost 0.5 for a couple of sine wave cycles, and if that current spike is enough to exceed the limitations of the output FETs, power supply FETs, whatever the case may be, at the temperature they're at, then they're just going to explode. And if they're at 16 volts and you have that much higher rail voltage inside, then that much more power is going to be asked to be delivered. So I don't really like the idea of running amps at 0.5 and at 16 volts unless you really know what you're doing and you are not asking for, you're not going anywhere near clipping, you know, because if you're not going anywhere near clipping, then you're not asking for excessive amounts of power. But if you're running the amplifiers up to clip point at 16 volts and you're 0.5, best be praying. Yeah, it takes 18 volts max, but even so, it's still pretty risky. If you're running a 0.5, I would probably just run a standard like 14.6 volts or something like that. Oh, that's why I could get my Logitech amp to protect on kicks. Yeah, partly that, but also kicks, like kick drums in music. The kick portion of the, you know, if you listen to a piece of music, you'll have like the bass kick. The first kind of bit of that sound bite will be a much higher frequency. It might be like somewhere between 80 and 150 hertz, that initial transient, and then the fundamental resounding tone of that bass kick will be the lower frequency, maybe between 30 and 60 hertz, right? So the higher frequency first transient, there's a lot less impedance rise there anyway, because the driver isn't moving as much, and the driver, if it's a subwoofer like a car sub for example, it's nowhere near as efficient at that higher frequency. So yeah, it's going to draw a lot more current from the amplifier on the kicks anyway. Sam, Sundown Repair, if you had put the amp back together... Wait, hang on. Was there a different question above here? Sundown Repair, if you had put the amp back together, it may have gone bang. Nice one. You didn't. Oh, the one in my video. Ah, yes. No, it wouldn't have gone bang, but it would have just had no sound for no reason, randomly. Did you fully fix it already, and is it for your new car build? No, the Sundown amplifier in my bare clips video that I whacked up on my second channel was a customer repair. Yes, it is all fixed. I repaired the trace and it's good to go. It needs endurance testing, but yeah, it's fine. Thank you for showing the trace under the caps. I commented on that NS1 video and I wanted to see it. Yep, glad you got to see it. What impact does high dampening factor provide on a sub-amp? What is an acceptable dampening factor for a good quality sub-amp? So dampening factor is not really a thing you need to consider anymore these days. Dampening factor was something that mattered and was important a long time ago. I'm talking like 60s, 70s, 80s, when drivers were very, very, very soft and very weak. The motor coil relationship was very weak in the driver. They were incredibly soft suspension. They didn't have a lot of mechanical compliance, and amplifiers were using really high on-state resistance, like semiconductors in the output section, whether it was tubes or whether it was really early transistors, really high resistance parts, really. And so the dampening factor is basically the resistance, the impedance that the subwoofer coil sees when it moves back to the amplifier. So obviously a coil moving in a magnet generates electricity. So if the amplifier has stopped providing a sine wave, stopped providing any signal, any music, and the driver moves from an outward position back to rest, then it's generating electricity. And that electricity, that wire, is connected to the amplifier, and so the dampening factor is basically the resistance, effective resistance, that the voice coil in the driver sees when it's moving back to rest after the signal has finished, for example. And with older amplifiers, you had a lot higher resistance components inside, so the resistance was higher than in modern electronics. And when the resistance is higher, that movement from the outward position back to rest wasn't really electrically dampened, so it would move quite freely, and then the driver could sort of wobble. You know, obviously if you just let go of the driver from an outward to an inward position, it's going to kind of wobble backwards and forwards before it stops. And it's deemed better amplifiers that have a higher dampening factor have a lower resistance. Therefore, when the driver goes from outwards to rest, it's harder to move. If you check this, if you've got a speaker laying around and you short out the connections and you try and move it with your hand, it's very hard to move. It becomes very stiff. So the lower the resistance that the driver sees from the amplifier, the better the dampening effect of the whole system. Anything over a dampening factor of 300 is being deemed basically indistinguishable with anything. Like anything over like 300 to 500, you can't tell any difference, especially with modern drivers, because modern drivers are a lot more mechanically controlled. The suspension systems are a lot stiffer, and they're a lot more mechanically dampened anyway. The motor to coil relationship is a lot stronger these days, so they're generating a lot more current when they're moving freely back to the amplifier anyway, so therefore there's more dampening. And also modern amplifiers, especially Class D amplifiers, have really low output impedance to the speaker. So yeah, between amplifiers, anything over 300 is going to be completely not really a factor you need to consider these days. Do amplifiers behave different on a car than they do on the bench? It'd be nice to monitor the rail voltage while it's playing in the car to see if it goes above the capacitor limits. It won't go above the capacitor limits typically unless there's a fault. Although half-bridge amplifiers do suffer from something called bus pumping, where if you are playing into a low resistance load and you are playing very low frequencies, then the kind of behavior of the output section can cause the rail voltage to creep up a little bit. It's called bus pumping. Maybe I'll make a video on it at some point. But the behavior of how the current is drawn across the output section and how the output inductors are working, etc., can cause a bit of creepage on the rail voltage. it's not really an issue you need to worry about most of the time. But half bridge amplifiers are susceptible to that, but full bridge amplifiers are not. So that's another argument for full bridge amplifiers potentially. But if you monitored the rail voltage while the amplifier was in a car and playing like loud and hard, then you would see the rail voltage has a little sine wave riding along the rail voltage at double the frequency that you're playing into your sub. And that's what you'd see. So you just barely see the rail sag. Thank you for taking the time to answer so thoroughly. No problem at all. Thank you very much for the kind donation, my friend. I really appreciate it. That's really kind of you. So let's say if we have an impedance rise and only play in the area where we are above 1 ohm, for example, could we still kill the amp? Well, as I explained, the amplifier is always going to see basically what you're wired to for a few cycles of the sine wave. So it depends on whether it can take it or not. And all amplifiers are different in that regard. Is it possible to bypass the preamp of the power amplifier? Well, yeah, you can bypass it simply just by opening up all the filters, by increasing the low pass filter to full, decreasing the high pass filter to minimum, and all that. So if you still want to bypass outside of those limitations, then yes, you can do it. You just have to know where to jump over on the board. You have to jump over from the initial first buffer op amp into where it goes into the output stage. You can do it, but it's not necessary really. The video on the Smart and Big Boss amps was a good explanation of how they don't work good together. I never thought about the limiter causing issues between the two amps running together. Yeah, so I haven't personally seen like two amps running together having the issue, but when I think about how they work and how they limit, and I think about how you can have two subs in the same build but have loading differences because of where the port is or which door is open, it's going to be a problem. I like it. There's no doubt about it, it's going to be a problem. So I just wanted people to be aware of that. What's up, these nuts? Good to see you here, my friend. Please tell me which class D amplifiers are more reliable, those with self-oscillation or forced generation of the carrier frequency. It's not that specific design choice that really makes a class D amplifier reliable or not. It's a lot of the other design choices that are going to be, around that. Having a fixed carrier frequency is probably preferable if I think about it now. So with car amplifiers, they are designed to accept a range of input voltages from like 9, generally amps work from 9 to 16 volts, or some work from 9 to 18 volts, right? And with self-oscillating amplifiers, what you'll find is that the Class D oscillation frequency, the switching frequency, is actually dependent on, and it varies with the rail voltage, and you can see that on any, like especially the Korean amplifiers that are self-oscillating, any car amplifier that's self-oscillating. If you put the oscilloscope and you look at the Class D switch wave and you change the voltage on your power supply from 9 volts all the way up to 14 volts, 15 volts and down again, you'll see that the frequency gets faster the higher the voltage is. So with a Class D amplifier output section, there will be a perfect calibrated frequency that circuit is running at its most stable and its most efficient for power delivery and switching characteristics. So where you have this behavior where the switching frequency is varying depending on the voltage coming in, well, you're never going to be in that sweet spot all the time. So, and from a design standpoint, do you choose that sweet spot at 12 volts? Do you choose it at 14 volts where people are mostly going to be idling and running the amplifier? So yeah, thinking about it, probably having a fixed frequency is the best solution, because then you can really make sure that your output section is always running in that sweet spot where the frequency is perfect. I mean, the frequency doesn't vary by enough probably to be a big problem. Like I wouldn't say stay away from self-oscillating amplifiers as a result of that, but if you had the choice, if you're starting with a blank sheet and you're like, right, do I go self-oscillating? Do I go for injected carrier frequency? Probably fixing the frequency in my head right now, just thinking about it on the fly, seems like the sensible choice. One funny thing which Taramps have done, which is really not, it's really janky and really bad in my opinion. Any amplifier that is running a single positive rail voltage, like a lot of the Brazilians do, they just use a single positive rail, yeah, and it's paired with IRS 2092 drivers. The way that circuit, the way that the IRS 2092 driver works, means that so basically for a Class D amplifier to work at its best, you know, to work the most effectively at idle with no signal going in, the the duty cycle on the Class D waveforms is 50%. So the way that you get 0 volts on the speaker terminals when no music is playing is you have 50% positive rail, 50% negative rail. So if you've got 100 volts for one half of the time and negative 100 volts the other half of the time, when you even those out with a low pass filter, you end up with 0. 100 minus 100, 0. Okay, so that's how Class D amplifiers work, and that's how it makes the most sense, because then when you've got 50% and 50%, that means that the sine wave can swing up to positive rail and down to negative rail equally. With the 2092 based circuits, that in the Taramps HD 3K for example, and actually even the Smart Series amps, I think they're all using 2092 still. But any amp using 2092 in the output section that's a single positive rail voltage, because of how the 2092 works and how its ground references work with relation to signal coming in, the amount of rail voltage varies the duty cycle of the Class D PWM. So the higher the rail voltage, the smaller the duty cycle gets. So when you have 14.8 volts going into a Taramps HD3K, for example, instead of being a 50% duty cycle on Class D, you end up with something like 38% or 42%, somewhere around there. Now, because it's full bridge, you have 42% duty cycle on both positive and negative terminals, so there's no DC offset of the speaker. That's fine. But what it does mean is that you're closer now to the negative rail, aka ground, because it's a single rail amplifier, than you are the positive rail. So when you're running these amplifiers at 14.8 volts, for example, at a higher rail voltage, when you hit the clip, when you turn the sine wave up and you hit clip, you actually clip off the bottom of the sine wave way before the top, because it's not balanced anymore, because the duty cycle is not 50%. And that is one of the drawbacks of running a 2092 with a single positive rail voltage, and I don't think Taramps really thought about that. But I just thought I'd throw that in there because I found that funny when I discovered that. Also, a video a long time ago, how to bridge mode any amplifier. Jesus, that's going back some time. Yeah, you could definitely do it a lot easier with my knowledge now. Something like that works on my integrated amplifier because I just do some to invert the phase of the other channel. Yeah, yep, it works well. I bridged my Technics amplifier for years with that method. I recently bought a DSP amp that has no crossovers and just gain. So the crossovers are going to be obviously in the DSP software. You'd have to calibrate it, set it up, plug it into a laptop, whatever. So, did I order my parts I need? Let's have a little peek. Have I checked out yet? Oh, I haven't checked out yet. So I'm just going to check out and definitely purchase my 24 N40s for this. Yep, that all looks correct. Place order now. Awesome. Oh, I have to confirm with my bank. 1 second. approve. £61.55 for 30 FDA 24 N40Fs. Not too bad. Oh, Firefox has literally just crashed again, just as my order was going through. I wonder if it actually went through. Yes, it did go through. I just got a confirmation email. What is wrong with Firefox? Guys, RIP Firefox. I need to open it back up again because I need the chat. There we go. So no, the only reason I don't use Firefox, but the only reason I'm using Firefox during my live streams is that if I need to open something on a browser, like to show you guys, I don't really want to open my Chrome just because I might have like personal things logged in there, or you know, it's just the browser I use every day. It might have, yeah, there just might be things on there that I don't necessarily want to show on live. So I use Firefox while I'm streaming, which is I don't use Firefox, so it's just a blank slate basically. Thank you. By the way, Sam, thank you. Repaired with your vids. My first amp, Excursion HXA2K, generic class D, but I smoked it again because the core was a bit too loose. Well, you can fix it again. You fixed it once, you can fix it again. Nice. I'm really glad that you got it back up and running, man. That's awesome. Right, so parts are ordered for this. Let's get this off the bench. I don't super have a plan for this evening. It was just really like a chat and catch up with you guys. Bit of a chat. Sam, crazy question. How many different subs do you think you've bought and owned over the years? I had this question recently actually on Slimewave02's TikTok. I haven't really bought and sold like a wild amount of subs. You know, I've had systems, but not like, I haven't gone through crazy amounts of subs. Like some people just go through systems and go through subs like crazy. I'm very sentimental. I tend to hang on to stuff. So it's probably something in the region of like 30, which really is not that much compared to some people. Hey Sam, you inspired me a while back as well to get into repair. I fixed a few of my own out. Nice! Freaking awesome. What exactly have you repaired? Hannibal, actually I recognise your user. You definitely have been jumping into these live streams for years now, so thank you very much for your support. And I'm really glad that I was able to get you into repairing some bits. I've also bought a broken CT Sounds 4K for €40. Yeah, that's not a bad price at all. Next project seems mostly output section. Those are just generic Koreans, aren't they? CT Sounds. So yeah, that'll be easy to get up and running. Nice cheap parts at the moment as well. Nice cheap FDA output FETs. I'm pretty sure that the drivers, the IR21844S, they're in plentiful supply at the moment as well. So it's a good time for repairing Koreans at the moment, I think. So let's get this back on the top shelf, out of the way, out of sight, out of mind. Yep. There we go. So what can I just look at now real quick then? Let's have a look. I'll tell you what we can look at. I will show you this. This is a Zapco DSP. This thing failed hard. Let's have a look. Where's the board in this? Oh, here it is. Right. So just this one real quick. Here is a Zapco DSP. Now, these things are plagued by power supply board failures. So this is the power supply module, power supply board for the Zapco DSPs. So what we have, if I remember rightly, I did reverse engineer this a while ago. We've got 12 volts coming in, obviously. Then I think that we've got some step downs for 3.3 volts and 5 volts, I think, which I think is handled over here, and that sends constant supply to the main board over here, which is constantly running like some of these chips over here, even when this is off. And when you hit the remote or you press the power button on the remote controller, then it powers up this circuit here, which takes 12 volts and steps it down to, I think we've got some voltage regulators here which are programmable with these resistors. We've got a couple of voltage regulators over here. Now what happened with this one is that one of these diodes here, yeah, we've got 5 volts and 3.3 volts, which is strange because it already generates those elsewhere for standby, but I guess we've got standby 5 volts and 3.3, and then we're going to have like main running 5 volts and 3.3. But anyway, it's one of these diodes failed and it took out the whole thing. I think it was this one or this one of these two was completely shorted, and so it took out one of these chips. It took out the rectifier, which is missing here, and it also took out the two little SOT23 MOSFETs here. They're tiny little surface mount MOSFETs that are running the transformer. So basically I replaced all of these bits here, including the MOSFETs, but when power is applied to this board, to, you know, when you ask the unit to turn on, these MOSFETs get extremely hot and draw immense amounts of current instantaneously. So that means that there is a short somewhere, but there's no shorts after the transformer. The MOSFETs are the correct model. The MOSFETs are driven by self-oscillation. There's no drivers. There's a kind of self-oscillation going on, probably with the inductance of the transformer primary or something like that. I don't know enough about how that works, but there's no driver, there's no PWM going in. The MOSFETs are kind of oscillating by themselves around the circuit here, maybe something to do with this inductor as well, I'm not sure. But there's nothing wrong with that. I think that the transformer has a short inside. I think it's got a shorted wind, because I started lifting some of these legs here, and eventually I got to the point where there was no more current draw and I was getting switching. So yeah, pain in the ass. You can't get these. So the only real way that I can get this up and running again is potentially to dismantle and rewind this transformer. I thought they used a crystal oscillator. I don't think so. There's definitely not a crystal on this board. There's no clock signal coming into this board. The gates don't connect to anywhere like these pins or anything for these FETs. So yeah, it's not a crystal as far as I can see. It's sort of self-oscillating. Yeah, these are ridiculously expensive pieces of crap. These are honestly awful. We need a candidate for chat fixes an amp. That was good fun. It was good fun. It didn't do as well as I'd hoped on YouTube, but it was fun. So yeah, I was going to, when I had some free time, remove this transformer and see if I could identify whether there was indeed an internal short. But I can't quite make out from the traces. It's a surface mount one. I can't quite make out from the traces like how many primaries and secondaries it's got, because there's a whole bunch of pins here, so there's going to be like a few different winds going on, and I can't, because obviously when you measure a transformer on the board here, most of these pins show continuity with each other, because you know you're just measuring the DC resistance of the winds, and sometimes they're like in series or whatever, I don't know, but yeah, it's very difficult to actually work out where the primaries and secondaries are, how many there are, etc. Yeah, this is the Zapco DSP Z16V. DSP Z16V. Nah, so the transformer will be custom wound for this. Like, you can't, you know, there's not going to be one that's even remotely compatible. You're going to have to get a direct replacement. So yeah, I think I'll put this one on the back burner for now, because I just feel like it's going to be a headache taking the transformer off and trying to, like, what if there's not a short in the transformer? That would be the worst thing, but I can't find anything else wrong anywhere else. So the fact that there was such catastrophic failures going back from here, the rectifier was dead. Like, to kill a rectifier, like, they're pretty sturdy, they're pretty robust. Rectifier was dead, power supply FETs were completely cooked, so some pretty crazy current must have gone through the transformer, and this is pretty small, so you know the wire in here is pretty small, so it must have got really cooked, it must have got really hot. So I wouldn't be surprised if it has shorted winds. It looks a little bit discoloured here. When you pull this back a little bit, I did pull this back a little bit, and it does look kind of fresh in there. So like, if I immediately saw like black, then I'd be like, oh yes, but actually you don't immediately see black. You just, like, it looks kind of fresh on the top at least. Doesn't necessarily mean it's fresh all inside, but on the top there it's fresh. So it made me a little bit like, oh, do I really want to unwind the transformer? Just what if it's fine? And then I've just like wasted a bunch of time and like. So yeah, that's where I'm at with that. But I can't find anything else wrong, but the MOSFETs just absolutely cook as soon as you apply power. So I'm not sure. But if I can get it fixed, it'll be great, because obviously it's an expensive unit and it'll be a decent repair bill, because I've spent a lot of time on it. But yeah, it's not very simple. I might try and see whether I can get a replacement one of these whole boards. ZDSPV. So if I can get a replacement one of these boards, then I can actually use that known working board to work out if the transformer is actually bad or not. Yeah, no wonder. So yeah, anyway, it was a lovely catch up, guys. Thank you very much for joining. Thank you very much to everyone who posted questions. It's been great catching up and chatting with you guys. I'll try and do some more of these, but life is very spontaneous at the moment and I have no idea. I might do a live stream later this week. I might do a live stream in another 4 months. Who knows? But I'm sure you'll be here for it regardless. Thank you very much. Have a great rest of your day, and I'll see you next time.